Okay, consider the function y equals x to the 2/3. This is kind of a fine detail, but calculus people can get into serious knife fights over whether something is a minimum or a maximum or not, so it's worth knowing something about this. If you have this function, y equals x to the 2/3, let's pretend the question is just find the local extrema for this. We would take its derivative, which is 2/3 x to the minus 1/3, which is the same as 2 over 3 cube root x. And now when we're looking for places, for points of interest on this derivative, places where it's either 0 or where it's undefined, it turns out there are no places where it's 0. But there is a place where it's undefined, and that's when x is exactly 0. And so if we look at what the behavior is like around 0 for our derivative, well, we have 2 over 3, which are positive, so those don't matter a great deal. We can do this whole thing in one bunch. It's 2 over 3 cube root x. If x is negative, its cube root is negative, and so the derivative is negative. If x is a positive number, then its cube root is positive, and we get a positive here. And if x is 0, its cube root is 0. Sorry, it's supposed to be a cube root. And 2 divided by 0 is undefined. Now, this doesn't just mean we walk away and give up. It's still possible to do something with this point if certain conditions are met. Here's what's happening at that corner. The function is coming down, curving like this. It's like a page of an open book. It drops, it drops, it drops, and at the right at 0, it technically goes vertical. And then it recovers and comes back the other way, increasing. So we have our decreasing side and our increasing side. The trouble is, right at this point, because the line is behaving like it's vertical, its slope becomes infinity or undefined, and that means the derivative becomes undefined, which gives us a bit of a problem. But a corner like this, which is known as a cusp, is still considered a local minimum if this point exists. If this point is defined on the original function, even though the derivative is undefined, we say, well, we can live with that as long as this point is actually there in the original function. So the question now is, if we go to this function and put 0 into it, is it okay? Well, we get 0 to the 2/3, which means 0 squared and cube rooted. 0 squared is 0, and the cube root of 0 is just plain old 0. So yes, that is all right. This point does exist, and therefore we can consider 0, 0 to be a local minimum. So normally when we're teaching you these, we tell you a local minimum is downhill, flat, uphill. It's also permissible to have downhill, undefined, uphill if you can show that that point is actually defined. If this point is undefined, then forget it. If you have the derivative goes undefined and that point doesn't even exist, then there's actually a hole in the function and we can't talk about a local minimum here. And all this stuff is true for a maximum as well. If you have a curve that's doing this, if that point is defined, then yes, fine, you have a local max. If that point is undefined, then no, you do not.